let's take a look at our lesson for today. So today we're going to look at something called implicit differentiation. Before I start with the process, I want to talk about what the difference is between an explicit and an implicit equation. So an explicit equation is one that is solved for a variable. So for example, we're familiar with this one, y equals, I don't know, so 3x cubed plus 2x plus, I don't know, sine of x, whatever. So notice that it's solved for y and it has x's on the other side. So this is called an explicit equation. And when we take the derivative of it, it's pretty straightforward. We have talked about that and taken the derivative of something that looks like that before. Now, implicit, those are equations where the letters are all jumbled up. One is not solved for the other. So an example of an explicit equation would be something like, xy plus cosine of y is e to the xy plus x cubed. I mean, there's x's and y's sprinkled all over the place. And trying to solve for x or y would be extraordinarily difficult and really not worth trying to do it, because we have a different technique that we use when we are taking derivatives implicitly. So this should say implicitly. So steps for taking the derivative implicitly. First, we take the derivative, and each time we take the derivative of a y, we tag it with dy dx. Okay, now the things that I'm saying right here might not make any sense, but when we start working through problems, hopefully you'll be able to refer back to these words. So we take the derivative. Every time we take the derivative of a y, we tag it with dy dx. Then what we do is we move all the terms with dy dx to one side. It doesn't matter which side. It doesn't matter at all, just one side. And everything else to the other side. Then we will factor out the dy dx. And then we solve for dy dx. We do the same thing every single time. So as you can imagine, with the steps that I'm talking about, there's going to be a lot of algebra involved. A lot of algebra. Yay. All right, so let's practice. Let's do our very first one. So I really need us to be paying complete attention, because this process can be very confusing. I've had students, and as I go through, let me explain. When we take the derivative of something with the y, that's the only time we tag it. So I'm calling tagging. Let's do that. So we are supposed to find dy dx. That's our job right there, dy dx. Which variable are we concerned with? We're concerned with the x. If you recall the with respect to, and I can write that out, it's abbreviated with respect to x. That means that this is the main variable. This is the one we want. And when we are taking the derivative of something that's not x, that's when we have to, what I call, tag it. We have to tag it with this dy dx. Okay, because that's the one variable we're supposed to be taking the derivative of. As we look at the first one, we see it's a y. Okay, so that's not our derivative that we want. We want x, but still we have to take the derivative of it. So the derivative of y cubed is 3y squared. And since it's not our preferred variable, we have to say dy dx. Okay, minus the derivative of 2x is 2. That's x. That's the variable we want. I don't need to tag it. Some students get really confused with this, and I will show you. If you wanted to tag, you could tag everything. Here we would say dx dx if we wanted to. But what is dx over dx? It's 1, so I don't really need to write that. Okay, but if that makes you feel, happier, you can certainly write that. Equals. The derivative of x to the fourth is 4x cubed. Again, if you want to tag everything, you would tag it dx dx. Plus the derivative of 2y is 2 dy dx. Now I'm going to put a slash through the dx dx's so they don't, we know we don't need to do anything with them. Actually, I'm just going to erase them. Okay. Now, let me talk about an issue that my students had earlier, I guess last week or the week before, my other classes. Some students thought that they were supposed to just like do dy dx to the whole side. Okay, that is not a thing. I need us to be really clear. The reason that I put this here is because I had taken the derivative of a y. That's why I put it there, not just that I'm just deciding to put it everywhere. And the reason that I put this one here is because I had taken the derivative of something that was a y. That's why they appear, not just because every side gets one. Does that make sense? It just appears when the variable that you're taking the derivative of is not an x. All right, so we just did step one, and we'll look at, so step one was take the derivative. Each time the derivative of y is involved, tag it with dy dx. Number two, move all the terms with dy dx to one side and everything else to the other. Now, you can see that I have one on each side. It really doesn't matter which way we go. But I will tell you that if I decide to go dy dx on the left and you decide on the right, we're going to have the exact same answers, but the signs are all going to be opposite, and that's okay. Does that make sense? The signs, and I'll show you what that looks like. So I don't know, what do we do? I'm going to move the dy dx's to the left just because. So I've got 3y squared dy dx. Okay, that's a plus, so minus 2 dy dx equals 4x cubed, and I'm going to move the 2 over. Okay, so that's step two. Get all the dy dx's on one side and everything else on the other. Step three, factor out the dy dx, and we just want one. We only want one dy dx. That's why we're factoring it out. Okay, so we are going to factor it out. So dy dx 3y squared minus 2 equals 4x cubed plus 2. Okay, so I did step three. I factored out the dy dx. Now we look at the very last step. Now it says solve for dy dx. In other words, get this by itself. Make sure dy dx is all by itself. So we're going to go over here and we're going to divide both sides, and I'll just show the division part. We're dividing both sides by 3y squared minus 2. And you can see that those go away, and I have my dy dx is 4x cubed plus 2 over 3y squared minus 2, and that's my answer. Now see how the derivative has a mixture of x's and y's. That's typical for implicit differentiation. That's typical. Yes, ma'am. Yes. Yes. So if they were fractions, I would still factor out the dy dx and leave the fraction there, and then I would have to, get it. Then that would make a complex fraction, right, when I divide by it, and that would just involve a lot more algebra. Yeah. Any other questions? Okay, so that's our very first implicit differentiation. Notice the amount of algebra we have. There's a lot, right? It's a lot of algebra. This lesson has a lot of algebra. So you get to practice all your algebra skills. Yay! Y'all are like, stop. Okay, here we go. Let's look at page 2. Okay, so this is a kind of weird looking. I want us to kind of focus on this side for just a moment. I want to talk about it. So this is chain rule, and this is the outside, right? We did those boxes before. This is the inside. So we have to take the derivative of sine, then copy paste the inside and multiply by the derivative of the inside. Remember all that, the chain rule? Now, this is actually, just going to be perfectly honest with you. See this little innocent looking thing right here? This is probably the main reason I have a stamp that says product rule, XY, because it's a product rule. That's product rule. Anytime you have a product of two functions, it's product rule, period. Okay, it's so easy to be, well, that's so easy, you know, that's just XY. No, that's a product rule. So please keep that in mind. So here we go. The derivative of the outside, the derivative of sine is cosine. Copy paste the inside. Don't even look at it. And I took the derivative of cosine. I'm not tagging anything yet. Times. Now I have to take the derivative of the inside, and this is product rule. That's what it is. So let's remind ourselves of the product rule. FG plus FG, first things first, second things second. All right, so the derivative of x is 1. Copy paste the y plus. I didn't take the derivative of y yet, have I? No, I have not. I took the derivative of x and it was 1. Plus, copy paste the first one, x. The derivative of y is 1 dy dx. And that's my chain. The derivative of 10x is 10. I want to pause there for just a second. That's really all the calculus right there. That first step is all the calculus. Now it's all the algebra. So we have to figure out how to release the dy dx from the parentheses. So yes, you guessed it. We're going to have to distribute to each of the terms. Okay, we can do that. That's not a problem. So when I multiply cosine xy times y, I'm going to write the y first just because it's cleaner. I don't really want to put anything by this. This is the argument, right? This cosine xy is the argument. I hope none of us in here believe that I can make that as cosine x times cosine y. That's not a thing. Not a thing. Okay? So y times cosine y plus x times cosine xy dy dx equals 10. All right, I want to put my dy dx to one side. So I'm going to keep this over here on the left, and I'm going to move the other stuff to the right. So I have x cosine xy equals, or dy dx, equals 10 minus y cosine xy. Now my last step is to solve for dy dx. So I'm going to divide both sides by that x cosine xy. So here you could move the dy dx to the front, yes, and put but this is linked together with multiplication, right? It would just be a difference in the way I wrote it. So up here, I couldn't put the dy dx up here because this one doesn't have a dy dx.
Right, well, on the last one, you just said it because there was 2 terms.
Correct, because there were 2 dy dx's. That's exactly right. And I had to factor them out of both. Because we want to end up with 1 dy dx in our work. Otherwise, that's just crazy, right? We need to know what dy dx is. That's our goal. Okay? So now I divide both sides, and I'm not going to show that step if y'all are okay with that. I'm just going to, divide both sides by that x cosine xy. So I have 10 minus y cosine xy over x cosine xy. Okay, so now what I'm going to do, now this is perfectly fine. We could leave it here, all the work that you do for me. That's as simplified as we can get it. Actually, we could change the way that it looks. And I'm going to show you a simplification of this. It's not required. I'm just going to write it down here so you can think about it. If it were multiple choice, the answer would probably look like this. So I just want you to be aware that just because your answer doesn't look exactly like all the answer choices doesn't mean it's wrong. This is another way to write the answer. Okay, so let's just compare them just for fun for algebra. Okay, if you can imagine, what did they do to get that? So they took this, they left, notice that this x is right here and this x is right here. They left the x there. Okay, but notice what they did. They took these and made that a y. You see that? And they took these and made 1 over cosine secant. And they also went to the other side. Okay, just for instance, just so that you're aware that if you get this answer right here, it doesn't mean if none of the answer choices look like that, it doesn't mean you've gotten it wrong. It just means that they probably did something to it, and see if you can figure out which one matches. Does that make sense? Okay. So what they did is they changed this to be, so they did it as 10 over cosine of xy, and 1 over cosine of xy is the same as secant. So they just wrote it using, that's where this came from. They just wrote it using the trig property. That's all. That's where that came from.
How did they get rid of the y cos xy?
Because they did y cosine of xy over cosine of xy, and the cosine of xy's go away.
Oh, can it go to both?
Say that again?
So the cosine xy can go to both?
It has to go to both. Yeah, it has to go to both. Right. I have those little yellow things. It has to go to both because it's the top has a subtraction sign in it, which means that this would have created two different fractions, right, that they would have added together. Does that make sense? Okay. So that's just something to be aware of. Okay, are we okay with this one? Okay. Now, number three is a good question, but for time's sake, what I did was, and this is in our content library, so you can always go and grab this, okay? You can always go grab it. What I did is I took number 3 and I just wrote the work for it over here. I know. Yeah. Talk about algebra. Maybe. So I would encourage you at some point to make sure that you see what I've done. So the derivative of natural log is 1 over the argument times the derivative of the argument. With me? 1 over the argument times the derivative of the argument. Here we go. That's 1 over the argument times the derivative of the argument, and the rest is algebra. This is the calculus part right here. This is the calculus part. The rest is algebra, and it's pretty intense algebra. So I would recommend that you go through and see the algebra and make sure you can do the algebra. But again, like I said, that's in our content library. You can grab it, and let me take that off. You can grab it and play with it. But for time's sake, I'm going to move on. okay? Because that's a lot of algebra, which was super fun. I'm not gonna lie, it was super fun. Okay, but we have other things to do. I got 2 more problems to do it, which also have some delicious algebra in it. So let's just go for it. Okay, delicious, yes, I know. Okay, so here we go. Number 4. They give us, we can tell that's definitely an implicit equation. We've got all kinds of y's and x's all sprinkled along there. They want us to find dy dx at this point, at that point. Okay, so our job first is to find dy dx, and then we're going to plug in a 1, 0. All right, here we go. So let's look at this. These are chains. This is the outside. This is the inside, right? That's a chain. The derivative of e to the, and maybe I've talked about this before, but the derivative of e to the box is e to the box times the derivative of the box. Because for some reason, e to the x kind of freaks some students out. Probably not y'all. Y'all are probably like, oh yeah, that's just fine. But some students, it just freaks them out. So the derivative. So the derivative of e to the 3y is e to the 3y times the derivative of 3y. The derivative of 3y is 3 dy dx plus. Okay, are we okay with that chain? So yes, I have another delightful little chain right here. We've got this outside. We've got the inside. So here we go. The derivative of e to the box is e to the box times the derivative of the box. The derivative of y squared is 2y dy dx. The derivative of y is 1 dy dx equals. So I'm going to pause there for a second. So that's the derivative of that little beast, if you will. So the derivative of x cubed is 3x squared, and the derivative of x squared is 2x. Now, I would really love to just throw numbers into it right now, but there's 3 different dy dx's, and I'm not really too keen on trying to figure out what that is. So I'm actually going to do some algebra first. I'm going to get it cleaned up and get dy dx equals stuff, so then I could plug in. Y'all, does that make sense? I wanted to make it look better so that my work is not so hard. So I've got 3 different dy dx's, 3 different ones to deal with, and I stayed on the left. So keep in mind that I'm going to have to distribute here, because that's kind of the algebra thing.
Why on the 2y dy dx plus dy dx? Why did you only replace the second y with it, and then on the first one you just put it next to it?
So the derivative of y squared is 2y dy dx, and the derivative of y is 1 dy dx.
Oh, okay.
Yep, I just did each derivative. I just didn't put the 1. Okay, anything else? All right, so now let's get our dy dx's together. Okay, so we've got 3e to the 3y dy dx. I just rewrote the order of it, so it's just a little bit easier to deal with. Plus, now I'm going to distribute. So I've got 2y e to the y squared plus y dy dx plus e to the y squared plus y dy dx. See all this delightful algebra? Equals 3x squared plus 2x. Yeah, the calculus was just in the first step. We're done with calculus. And typically some people will say the hardest part of calculus is algebra, and you can see why they might say that, right? Because the algebra is pretty intense. So now I have the 3 different dy dx's. I'm going to factor them out. So dy dx times, the first term was 3e to the 3y. The second term was 2y e to the y squared plus y. And the third term was e to the y squared plus y equals 3x squared plus 2x. Okay, so I factored the dy dx out of each term, and now I'm going to solve. So dy dx is 3x squared plus 2x all over 3e to the 3y plus 2y e to the y squared plus y plus e to the y squared plus y. Phew. Okay. So I want to pause here for just a second. Is everybody okay with that derivative? It's a crazy looking derivative, but that's what it is. Now our job is to evaluate it at 1, 0. So what I would recommend is that you write dy dx at 1, 0. That's the normal, typical way that you would show that you're evaluating the derivative at a point. You would put dy dx, you put that long little slash and write the point coordinates down there at the bottom. That's just the normal way to show what you're doing. Okay, so now I'm going to just go up here. I'm going to plug a 1 in for all the x's. Okay, so I plugged a 1 in for all the x's, and I'm going to go and plug a 0 in for all the y's. And I'm going to pause there for just a moment. Okay. So let's see, 3 plus 2 is 5. And what is e to the 0? 1. Isn't e to the 0 1? Yep. So that's 3 plus, and this 0 right here wipes out this whole middle term, doesn't it? The 0 times 2 times 1, so that's going to be 0. And then over here, what's this one going to be? 1. So out of all that craziness, we get the derivative at 1, 0 is 5/4. Okay, how's that? Everybody okay? Okay, the last problem is a free response problem, which you have one exactly like it, but different numbers in the AP Classroom. So we're going to go through it so that you can see it. Now remember, when you do the AP Classroom, you have to score the free responses yourself. Okay, you won't get credit for the AP Classroom unless you score the free responses yourself. With me? Okay. Here we go. So consider the curve defined by, okay, show that. I want you to look at this, show that. What does that mean? That's a typical thing to have to be asked. What does that mean? It means prove or go through the steps. That's what it means. So they basically gave you the answer. You're just supposed to just work it from scratch. Show that means just work it from scratch and get the same answer they got. That's what it means. That's really important because some students get really confused about what that means. It just means just work it out. So I'm going to take this equation and I'm going to take the derivative of it implicitly. Oh, look at this little innocent looking. What do we have to do? What do we have to do to take the derivative of that? Product rule. Look how innocent it is. It's not innocent. It is not innocent. It's product rule. All right, so here we go. So product rule was FG plus FG, first things first, second things second. Okay, so the derivative of x is 1, copy paste the second term, plus. Copy paste the first term, The derivative of y squared is 2y dy dx. Notice how I tagged it. Why did I tag that? Why? Because it's a y. I took the derivative of a y, so I tag it. Okay, that's the way it works. Okay, and then we take the derivative. That's just a nice innocent little negative 2x cubed. So that's just a regular old power rule. So what is that? Negative 6x squared. And you're probably not going to believe this, but I can't tell you how many times students ignore that and write down a 2. What's wrong with that? Because it's 0. It's 0. The derivative of 2 is 0. I can't tell you how many times that happens. Please be careful. Be very careful. Don't do that. Take the derivative of the constant and get a 0. All right, great. Great, great. So now we're going to get dy dx on one side. I like it where it is. Let's just leave it there. So 2xy dy dx equals, so I'm going to move the 6x squared over and the y squared over. Then we divide both sides by 2xy, and we verify that this is the same as this. That's what we're supposed to do. We just showed that that's the derivative by our work. So doing all those steps is proof that that is correct. Does that make sense? Okay, so there we go, part A. Okay, any questions on part A? All right, let's look at part B. Write an equation for the line tangent to the curve at the point 1, 2. So what do we need for tangent lines? Okay, what do we need for tangent lines? We need a point, which we have, and what? A slope. We need a point and a slope, right? We need a point and a slope. Well, where do we get the slope from? The derivative. We get the slope from the derivative. So, and I have the derivative right up there. So what do I need to do? I need to do dy dx at 1, 2 is, so let's plug those in. So that would be 6 times 1 squared minus 2 squared over 2 times 1 times 2. So I just took the derivative that I found up above, on which they listed for me. Why do you think they listed it? Because they don't want us to make a mistake, right? They don't want that to impact every single other question that we do, if by chance we got the derivative wrong. Okay, so we got that. So let's go through with that. So what do we have? We've got 6 minus 4. So 6 minus 4 over 2 times 1, so 4. So what is that? 2/4? 36. No, it's just the x that's squared, not the 6. Yeah. So it's a half. So now we're going to write it in point slope form, and we're going to leave it alone. Please don't distribute and combine like terms. Just leave it alone. So y minus 2 equals 1/2 times x minus 1. Stop. Don't do anything else. And we're done. Okay. How's that? We're going to be doing tangent lines like all year long. It doesn't go away. It's just over and over and over again. Okay, are we okay with this? Yes? Okay. Let's look at part B. Part B says, find the x-coordinate of the point P at which the line tangent to the curve of P is horizontal. The line tangent to the curve is horizontal. We need to dig into the words and figure out what this means. What does it mean for a tangent line to be horizontal? What does that mean? The slope is 0. So we're looking for the slope to equal 0. Okay, that's what we want, because that's what a horizontal tangent line is. And what does it mean to be a tangent line? Where do we get the slope of tangent lines? From the derivative. That's where we get it from, the derivative. So let's set the derivative equal to 0. And, the derivative was given to us at 6x squared minus y squared over 2xy. That's what it is. Okay, so that looks a bit crazy. First off, remember when we were solving these in pre-cal, just back in the day, right? Back in the day when we were solving. Remember when we were solving these, and we were right to the side what x and y can't be. In our case, we would have just said x. What can x not be? So we're going to write over here, x cannot be what? 0, because that would cause the whole equation to be undefined. And what can y cannot be? 0. Y can't be 0. So now I'm really not going to deal with this anymore, right? Because anything, it can't be 0. It can't be 0 down there. So like 0 over 2 or 0, we don't care what the denominator is. We just know it can't be 0. Remember that rationale from last year? You're like, sure we do. Sure we do. Okay, well, we're going to keep going on. So what we want is, 6x squared minus y squared is 0. That's what we want. Now, unfortunately, we have two variables in one equation. And we know from our experience with math, we can't do that. We can't solve two variables in one equation. We need two equations, or we need one variable. With me? If we have two variables, we need two equations, or we need to get it down to one variable. Now, we don't have, another equation, but we actually do have another equation. So let's kind of look back over here. We've got this. We've got that going on, right? How can we use that? How can we use this? That's what we want to think. How can we use that? Well, look, it's got a y squared in it. See that? See this little y squared right here? And see this little y squared right here? Wouldn't it be awesome if we could get rid of solve that for y squared and sub in? Yes, that would be great. That would be great. So that's what we're going to do. We're going to take this equation, this y squared minus 2x cubed equals 2, and we're going to solve it for y squared so that we can get rid of that y squared. We want one variable so we can solve. And yes, this is a College Board question. They expect you to be able to know how to do this. So we're going to solve for y squared. So I've got y squared equals 2 plus 2x cubed. Okay, so I'm isolating the y squared. I'm going to divide both sides by x. So this is what I've got. Now I'm going to take this and I'm going to put it right there because that's what y squared is. Okay, so let's do that. So I got 6x squared minus, and we're going to take that fraction, 2 plus 2x cubed over x, and just slide it right in there. Okay, now our job is to solve that. Now I'll tell you there's lots of different ways to solve it. I'm just going to show you what I would do. Lots of different ways. What would I do? I would move that fraction to the other side and I would cross multiply. That's just what I would do. That would make me happy. So I'm going to move this whole fraction to the other side. So 2 plus 2x cubed over x. And then I'm going to cross multiply. That would be like over 1. So I have 6x cubed equals 2 plus 2x cubed. I move the x cubes on one side, so I get 4x cubed equals 2. So x cubed is 1/2. 2/4 is 1/2. Then I cube root both sides. And I get x is the cubed root of 1/2. Oh, isn't that delightful? And there we go. Okay, how are we doing? One more. Now this one is also a lot of fun. So when I say it's a lot of fun, a lot of y'all know me really well. Okay, let's do this. So the part D, we want to find the second derivative at the point 1, 2. Now, I'm going to write down, so the first derivative is, just going to write it over here so that we remember. The first derivative, so dy dx, I'm just writing it down so we can see it as we're doing the derivative. Dy dx was 6x squared minus y squared over 2xy. That was the first derivative. Okay. So, to find the second derivative, this is going to be so exciting. Okay, so the second derivative, d2y over dx2 equals. What rule do I need to use here? What rule to take that derivative? Quotient rule. Yep, it's a fraction. We have to use quotient rule. No choice. Quotient rule. And the quotient rule is fg minus fg, first things first, second things second, over g squared. Okay, we got this. So the top is f. So I'm supposed to take the derivative of the top. The derivative of 6x squared is 12x. Derivative of the top. So the derivative of the whole top. The derivative of 6x squared is 12x. The derivative of negative y squared is negative 2y dy dx. I'm going to put it in parentheses. That's f prime. Copy paste g minus. Okay, so what have I done? I've done this first piece right here. So f prime g minus f, let's copy that down, 6x squared minus y squared times derivative of g. Oh, this is going to be fun. What do I need to do to take the derivative of this? Product rule. Look at our little innocent xy just hanging out there. Not so innocent. So what I like to do is I like to make like this part right here, f. This is for the product rule. And this part, g. Okay.
Quotient rule, why did you change the negative y squared to negative 2y?
Because I'm taking the derivative of the top, the whole top. That's the whole top. The derivative of the whole top is 12x minus 2y dy dx. That's the derivative of the whole top.
Okay.
Then copy paste the bottom, minus, copy paste the top. Now the derivative of the bottom. And the derivative of the bottom is a product rule. So let's write the product rule. Fg plus Fg, first things first, second things second. Okay, so the derivative of f is 2, copy paste g, plus, copy paste f. The derivative of g, which is y, is 1 dy dx. See how easy it could be to get mixed up here? There's so much going on. So much. All over the bottom squared. Now, I just want to share, if we were just finding this equation, what do you think we would have to do with the dy dx's? Do you think they could stay there? Nope. What would we have to replace the dy dx's with? 6x squared minus y squared over 2xy. Let's talk about some fun algebra right there. Right? You with me? You're like, no, stop. Okay. So instead, we're going to sub this point in. Now, we need to know what dy dx is at 1, 2, because we need to know that. Do we know that already? Didn't we find that already? Dy dx at 1, 2? We did, didn't we? Over here? Dy dx at 1, 2 was a half. You with me? Dy dx at 1, 2 was a half, and I'm just going to write that as a note up here. So dy dx at 1, 2 was 1/2. And that's what I'm going to put there, and that's what I'm going to put there. I'm just going to put a 1/2 there. Because right now, I don't know about you, but I mean, it would be fun to put that whole equation in and work through it, but I really think we have an easier way. So we're going to do d2y over dx2 at 1, 2 equals. So here we go. Let's start plugging in. So we've got 12 times 1 minus 2 times 2 times a half. I'm going to stop there. That's the first parenthesis. Then I've got 2 times 1 times 2 minus 6 times 1 squared minus 2 squared times 2 times 2 plus 2 times 1 times 1/2 all over 2 times 1 times 2 squared. That's a lot of numbers going on. Okay, equals. So 12 times 1 is 12. 2 times 2 is 4. 4 times a half, that's what, 2? Yes.
Why is the x tagged on the one with 2y plus 2x?
2y plus 2x. Are you talking about this part up here? It's not the x that's tagged, it was the y, because I was doing product rule of 2xy. And I did, so this right here, so I copied down 2x and I took the derivative of y, which is 1 dy dx. I'll put a 1 in there.
Okay.
Yeah. Okay, so we're subbing our numbers in and we're getting ready to have fun with arithmetic. Okay, are we doing okay? Yes, ready to keep moving? Okay, so I'm just cleaning up, trying to do my arithmetic with the first set right here, minus 6 times 1 squared is 6, minus 4. Let's see, I've got 2 times 2 is 4, plus 2 times 1 times a half is 1, all over, what is that? That's 4 squared, which is 16. So again, we're just doing arithmetic now. Okay, so what is that? That's going to be 10 times 4 minus 2 times 5 over 16. And most of y'all are probably way better at arithmetic than I am. You could do this in fewer steps. This is how my brain would work. I'd have to go piece by piece. So that would be, what, 40 minus 10 over 16, which would be 30 over 16, which would reduce to 15/8. And there we go.